I think we are all familiar with heat transfer by evaporation, right? This is what our body does. We sweat. When we sweat, the water evaporates from our skin, and we lose a fantastic amount of energy per kilogram, right? 3.3 times 10 to the fifth joules of energy per liter of water. And this is what we do, right? We get in trouble when we get dehydrated and we can't sweat, or if it becomes 100% humidity, then the water gets on our skin, but it doesn't make us cool because it can't evaporate. If the air is saturated, that's what 100% humidity means. It can't evaporate, so therefore it can't cool you. And just think about that. If it's 103 degrees Fahrenheit and it's 100% humidity, that's kind of hard on a human being, right? We want to be at 98.6 degrees Fahrenheit, right? So hopefully we can find a shady spot, right? So basically, Richard Feynman talks about how it works, right? If you think about a surface of a liquid, you have to picture these water molecules moving. They stay in close proximity to each other, but they move. Some of them, though, every now and then leap up into the air and come back down. They're attracted to each other, and so they'll return due to gravity and due to attraction. And some of them go even farther into the air and return. But the ones that escape have to be the very fastest, right? They've got basically an escape velocity. They're going fast enough to escape. Well, if you're always losing the fastest ones, what happens to the average of the ones that are left behind? Well, the average kinetic energy gets less, right? If you're taking away the fastest molecules, then the average of what's left behind is less. And that's, on a microscopic scale, that's how evaporation works. So obviously sweat is an example. The Science Building 2 at PSU actually has a swamp cooler, right? Basically, they cool down a building by evaporating water. And you can do this in places that don't get very humid. These are very popular in like Tucson and Moab. A little less effective in the Northwest, and they just wouldn't work at all in Galveston, Texas, where the humidity is 100%. But basically, the idea is that you just run water over something and then blow air through it, and it will immediately reach the dew point. That's that cold. You get out of the pool and you stand in the wind and you feel cold. Well, that's because it's cooling you down by evaporation. And then as far as personal, your personal use of evaporation, this is why you don't wear cotton if you're outdoors, right? You wear polypropylene or some kind of a wicking layer to keep your skin dry. And the typical death by hypothermia is that the person went on a hike, it started raining, and it got cold because it's the mountains, and all they have is a cotton sweatshirt, right? The cotton sweatshirt keeps you wet. Cotton is good for hot weather, not so good for like survival when it's cold because it keeps your skin wet. And so, yeah, there you go. All right. And then this is, wicking layers, right? This is the idea, so we get the moisture away from our skin. And this is actually, me. I just photoshopped myself out of there. But that's me wearing this Under Armour layer there. Okay. All right.